I'm going to talk about a few different ways to determine linear factors, and in particular, go over completing the square. Because if you have to do this, and your sole recourse is make it equal to 0, use the quadratic formula, and then try to remember how to plug it back into it, it's not worth it. Do a complete square. The technique, I think, is worth learning. So,
You complete the square a different way to how we were taught.
sorry?
You complete the square a different way to how we were taught.
Sure, I think I'm going to show you the way you were taught today. Sam, can you close that because they are getting a bit noisy? Alright, so, factorising quadratics over C. Complex numbers. So we're going actually I might use Z to remind you, BZ plus C, where A, B and C are real numbers, so we're actually factorising real quadratics, and A is not equal to 0, otherwise it's not a quadratic. That's what we're trying to do. You can use an X or a Z or a P or a Q, I don't care. As long as you know what the coefficients are and what the variable is that's squared. Okay. Step 0 is always look for a common factor. It's always, always, always. Do I need to show you what I'm talking about? 3z squared plus 9z plus 6. And you go, oh, the first thing I should do is take the 3 out. Always. Always look for that common factor first. Always. It will make your numbers smaller, simpler, make your job easier. Daniel, don't get distracted by that. So, number 1. What if C equals 0? You've done these many times. Okay, these first couple you've done many times. If C is 0, I have something like 3z squared plus 8z. How do I factorise that? Z, 3z plus 8. Now I have two linear factors. Okay, I have determined linear factors of quadratics. One more example. Negative 2 plus, no, I'll make it harder. 2 minus 8z squared. That's not right. I want C to be 0, I'm getting ahead of myself. 2z minus 8z squared. What's the common factor?
2z.
2z, 1 minus 4z. You've done these a million times in the past. Right? This is year 10 maths. Option 2, what if b equals 0? Well, if b equals 0, I have one of two things. Either I'm using different letters than x's and a's and b's. G squared minus h squared equals, and you can put the plus and the minus in whatever order you like, or I have this. Do you remember how we factorise this with a plus?
Use complex.
I use an I. Where do I put my I?
In front of the H?
Correct, or after, doesn't matter. Why? Because if I expand this out, this is going to cancel this, and this is going to become minus h squared I squared, but I squared is negative 1.
Yeah.
So plus h squared. Do you want me to do a few more examples of this? I did a couple the other day, do one or two more. Okay, a few nods. For example, let's do a simple one. Z squared minus 8. This doesn't look like a perfect square, but it's close enough, right? because it's z plus root 8, z minus root 8, and ideally you should go and simplify minus 2 root 2. Are my 2's and z's too similar?
No.
Should I put little loops in my 2's?
We can make it x.
I could use x, doesn't really matter. And similarly, suppose there's a plus. What if I go 5 plus, let's go 4z squared? Have a go. Maybe we can do it that way. Doesn't really matter. If it were me doing this, I'd probably organise it the other way first. Otherwise, the z's and i's are going to get in each other's way. I would write this first as 4z squared plus 5, and then go. What's the square root of this one?
2z.
Easy enough. And of course, sometimes the coefficient of your z squared or your x squared or whatever might not be a perfect square. That's fine. Just put another square root, another surd in front of the z. That's not a problem. Comfortable so far? Okay. 3. Sum and product. Now you're very used to doing this when the solutions are real. So for example, can I make up a real one for you? Z squared plus 8z plus 15. How do I factorise that?
Complete the square.
You don't need to complete the square for this one.
They do.
I need two numbers that
Oh,
add to 8 and multiply to 15. What two numbers add to 8 and multiply to 15?
16.
Or Ethan question.
So this is just z plus 5, z plus 3.
Sure.
If the number in front is not 1, you can still do this, but you might need a couple more lines. Go back to first principles to make it easier. What if I had this is harder to write, 3z squared plus 8z plus 15, no, plus 5. So the numbers are going to be the same. So it's still add to 8, multiply to 15.
Yeah.
Yeah.
So still 5 and 3.
Yeah.
But how do I then go the next step? For me, after many years of teaching this, I've decided I'm going back to first principles. Split this up.
Yeah.
3z squared plus 3z plus 5z plus 5. And it actually doesn't matter. If you get these the wrong way around, you'll still get the same answer at the end. Because then I go 3z, z plus 1, plus 5, z plus 1, common factor. You've done that before. You should have done that before in year 10. You've probably already done it in methods, in 11s, yes? So, it is possible to do this over complex numbers, but much harder. I will show you a couple, but just like doing it this way with the real numbers, if it takes you longer than 20 seconds, stop. And go to 4, which is complete the square. But it is possible in certain situations. For example, let me get my cheat sheet. What about this one? So I'm going to go harder over C. Not impossible, but much harder. There are some you could do. For example, z squared minus 4z plus 5. So you go, I want two numbers that multiply to 5 and add to negative 4. That was not very good. Can you think of two numbers that multiply to 5 but add to negative 4? Not in real numbers, right?
Negative 5i and 1.
You've got the right idea. They won't add to negative 4. But 2 plus I and 2 minus I will. Actually, this one. If I multiply these, notice they're conjugates, that's important. If I multiply these, I'm going to get 4 plus 1. I did that wrong, did I? Oh no, that's right. If I multiply them, I'm going to get 5. That's correct. And if I add them, oh, I've done something wrong. I did a negative, do I?
Should be both negative 2's maybe?
They should both be negative 2's, that's correct. You made something wrong. If I add them with negatives, I'm going to get negative 4 because this will cancel that. Okay, it's harder, but it's possible. You could then go, okay, z squared minus, actually I'm going to go plus minus 2 plus I plus minus 2 minus I plus 5. And you go, I can't, oh, I'm missing something, I'm missing a z. I can't factorise that. You can. Z, take 2 plus I, plus 1. What I'm looking for is, no, this is wrong. This is not right. I'm just going to skip that. This step is going to be too messy. It's going to turn into this. Z minus 2 plus I, Z minus 2 minus I. Factorising it is hard. Because if you expand this, you're going to get Z squared, this many Z, that many Z, plus 5. It is possible, is my main point. I don't actually recommend you doing this unless you can see very quickly what to do. It is possible. What I think you should do instead is go, if I can't quickly find these numbers, just complete the square. So let's do some complete the square. All right. Complete, oh, this was number 3. No, that was 3. 4. Complete the square. Now, let's see if I can show you the same method you once learned for this. Okay. 2x squared minus 3x plus 1. I'm hoping what you have done in the past is just turn this into a monic, yes? It does make it a bit easier most of the time. So the first thing we do is go 2x squared minus 3 on 2x plus 1. No. Aha, correct. Okay, then I'm going to go x squared. what are you used to writing next? Is that what you want? Or what?
No, we don't split up. We just keep it as -3 on 2x.
Oh,
And you
okay.
can say, oh, what's half of that?
Okay,
That way
that's
it's-
fine.
it's confusion.
No problem. You want me just to go -3 on 2x plus 3/4 squared. Okay. Okay. All right. So it's 2 times something. Well, this bit is x minus 3 on 4 squared. Minus 9 on 16 plus 8 on 16. Correct, but I may as well do that step now. Two x minus 3/4 squared minus, and now I have
Difference of squares.
difference of squares. 2x minus, whoops, don't need that now. X minus 3/4 minus 1/4. X minus 3/4 plus 1/4. And then simplify one more step.
You could have done the split method.
Correct, correct. But I wanted to show you that this still works. This one, yes, you can just use the normal split because it's pretty easy to solve these numbers. But I wanted to show you that this method will always work. It's like the quadratic formula. You can always use the formula. You can always complete the square. Even if in this case, it would have been probably quicker. This is, and this is, minus 3/4 plus 1/4 minus 1/2, which would have been the same as saying x minus 1, 2x minus 1, which we would have got from just factorising that. It was a long way, but it still works.
And in plenty of cases, it's easier.
When it's complex, it's going to be very, very difficult to do this. Very difficult. You are better off complete the square. Let me give you another example. 2x squared minus 6x plus 3. Do you want to have a go?
Sure.
Have a go. This one I think is still real. Because the next one I think we're going to need complex. Yeah, so I think this one is still real. Okay, now at least I know how you guys normally write that. So this has to be 3 on 2, which is 2x minus 3 on 2 squared minus a half. No,
Nah,
no,
3 on 4.
3 on 4. I thought I could simplify that, but I can't. Okay, so there's going to be 2x minus 3 on 2. Oh, wait, x minus 3 on 2. What am I doing wrong? That's not right. x minus 3 on 2 minus 3 on 4. X minus 3 on 2 plus 3 on 4. Oh no.
Yeah, it's square roots, I think.
Where have I got my roots? Oh,
Yeah,
root 3.
Yeah.
Thank you, thank you. That should have happened, yeah, here, that's right. 2, and that looks more like the quadratic formula, which is what I'm expecting. Minus 3 minus root 3 on 2, x minus, I don't think I got the signs right. I'll just do it that way. That's it. Will I give the hint that it's complex and make it a z, or are you comfortable with x? No votes?
What is it?
Who votes x? Who votes z?
Z.
Well, it's x, even though there's not many people voting. 4x squared minus 3x plus 1. So this one's going to be complex, I'm telling you now. And we're going to go. I need this, take the 4 out. 1/4. No, 4. What am I doing? 4x squared minus 3/4 x plus 1. No, plus 1/4. That's where my quarter is. What's my thing that I'm squaring? It's half of the middle. 3 on 8. And what happens next? Instead of a difference, I'm expecting to get a plus here. Let's do it in C. X minus 3 on 8 squared minus 9 on 64 plus 16 on 64. Oh man. Now I'm glad I didn't use Z. A 7 would have looked like it, very much like a Z. And so previously, when you get to this point, you go, I can't factorise this, it's got a plus. But now you're going to go, I can do the sum of 2 squares. I just need an I. X minus 3 on 8 plus root 7 on 8i. X minus 3 on 8 minus root 7 on 8i. And I factorise it to linear factors. And again, like this one, I would probably write it with a common bottom. Oh no, I can't quite simplify that. X plus negative 3 plus root 7i on 8. X plus negative 3 minus root 7i on 8. These are exactly the same. It doesn't really matter which one of these you write. But that is determining linear factors of real quadratic polynomials even when the roots are complex.